Strand 8. Topic is probability. Question number 5, part A. The question is, what is the probability that a randomly selected year 12 student has the height less than 151.9 centimeter? The mean is 150 and the standard deviation is 5. This is the question where we need to use the normal distribution curve, the bell-shaped normal distribution curve. Let's have a look at how the question looks like on the question paper. So that's how the question looks in the question paper. First of all, the table is given over here. We will be using the table to convert the Z value into probability towards finding the final answer. The heights of year 12 students are normally distributed with a mean of 150 centimeters and a standard deviation of 5 centimeters. Part A, what is the probability that a randomly selected year 12 student has the height less than 151.9 centimeter? And it says give your answer to 3 decimal places. So over here we will be using the formula Z score is equal to x minus mean divided by the standard deviation. So what we can do over here firstly is make a sketch of the normal distribution curve, a straight line across, and then a bell shape. The normal distribution curve. It says the mean is 150, so the center line, the middle line, that's the mean, and that is equal to 150. Standard deviation of 5. The bell shape has 1, 2, 3 standard deviations towards the right. 5 means plus 5, so that will be 155, plus 5, 160, plus 5, 165. And then 1, 2, 3 standard deviations towards the left. Now this one would be minus 5. This is 145, minus 5, 140, minus 5, 135 centimeters. And the question is saying less than 151.9 centimeters. Let's locate where that would be. That's 150, that's 155. So 151.9 would be somewhere there. 151.9. So the question is asking, what is the probability that somebody will have a height less than that? So we are talking about that range, and that is the whole probability that we are looking for. So the probability on each side of the normal distribution curve is half. The probability over here is equal to 0.5. The probability on this side is equal to 0.5 for the total. But what we're going to do is we're going to add this half to the probability of that section over there. So we'll use the Z score or the Z value formula to find the probability of that rectangular region from 150 to 151.9. So let's use the formula. The formula is Z value equals x minus mean upon standard deviation. X is that value, 151.9. That is the x value. So 151.9 and mean. The mean is 150. 150 divided by the standard deviation is 5. So the Z value over here we get by calculating is equal to 0.38. Now that 0.38 is the Z value. We have to convert that to probability because this is the probability normal distribution curve. Right now we found the Z value. To convert that to probability, we have to go to that table over there that is given in the question paper. We will be using that table. So 0.38. So 0.3 and then go up to 8 and then find that number. So 0.38 corresponds to 0.148. Just, let's see where it is. Just above that one, 0.148. So the Z value is that for that region over there, from mean to 151.9. The probability of this z value is equal to 0.148. Now don't leave your answer like that, because 0.148 is the probability of just that region. We need to add 0.5. So our final answer over here, is the probability that the question is asking for is equal to 0.5. That is the left hand side of the normal distribution curve. All the students falling below the mean, 50% of the students, so 0.5, plus the answer we found over here, the probability of z, 0.148. And remember, the question had said give your answer to 3 decimal places. So the final answer over here will be 0.648. That is the probability that a randomly chosen student will have their height less than 151.9 centimeters. So they will fall from that line towards the left of the normal distribution curve. Try to show all working out, so that even if your final answer is wrong, you can be awarded some marks for partially correct working out. This question is worth 3 marks. Thanks for watching.